Hello and welcome back. If you follow the channel, you know that we are in the midst of restoring the Apollo communication electronics. It started by us getting our hands on the S-band transponder and amplifier thanks to collector Steve Jurvetson, who later also got us the matching NASA ground test equipment. The project scope extended further when team member Marcel got us most of the rest of the comms system boxes, to the point that we now have a good portion of the electronics of the spacecraft. We are over a year into the project, and after having resurrected the transponder and reverted our ground equipment to their original Apollo configurations, we are happy to report that we got all three of the microwave carriers link going. The Apollo Unified S-band system, or USB for short, uses three microwave carriers. The uplink uses a phase-modulated or PM carrier, while the downlink uses two carriers, one PM modulated and one FM modulated. Each carrier is then used to transmit many things at the same time. The PM uplink transmits ranging, voice and data. Same goes for the PM downlink. The FM downlink transmits television, scientific data and recorded data. To make things even more complicated, there is provision for EVA VHF relay, LEM relay, biometric data, plus a whole bunch of redundant and emergency modes. To do this, the USB uses subcarriers, which is a common radio multiplexing technique. Information is modulated on a subcarrier, then the resulting waveform is intermodulated on the main microwave carrier. NASA went even further, using that technique recursively. For example, take the amusing case of the up data modulation technique. It employs 4 stacked up modulation layers, and we end up with a quadruple modulation scheme. Up data is PCM on PSK on FM on PM. All that to say, now that we have the carriers going, our next job is to get all that subcarrier modulation going. In episode 12 and 15, we already reconstructed the full modulated uplink, but we cheated a bit using modern Keysight equipment, and it still took quite an impressive stack of modern electronics. But of course, we want to do it the original NASA way. Our NASA test system has regrouped most of the subcarrier modulation functions in a box called the interface simulator. That's the very box we are going to try to revive today. If we succeed, it should replace the whole stack of modern Keysight equipment that we used previously. So today on the bench we have one more of the test boxes, which is the interface simulator. This one has a lot of things. It's part of PMP on the transponder side, and it does what my pile of HP boxes did on the uplink side. This is basically 30 kilohertz voice up, it says voice, that should be 30 kilohertz. That is aux, we figured out, that's for the ranging code up, and that's for the command up, so it should hook up to our big command box. By the way, if you look at the front panel markings, you'll notice that one side of the box is labeled STE. That stands for S-band test equipment. That's the Earth side with the signal inputs for the uplink. The other side is marked USB-E. That's the nickname NASA gave to the USB transponder amplifier combo. So the USB-E side is simulating part of the PMP on the spacecraft side. Thanks to Marcel, we do have the real PMP, so we should not need this part of the simulator. But it's still a nice extra to have. So that's all the ground uplink subcarriers. And here is a combination of up and downlink that hooks up to a transponder. So this is a TV down, and then we figured out this has this just adds bias on it. That's the problem we had, that when we tried TV, it would it would pull the FM frequency, and it turns out they knew about it, so they had put a little bias to avoid that. That is on the way up. So apparently it gets the receive 70 kilohertz and receive 30 kilohertz. Basically that's the voice that comes up, and for some reason it has 50 kilohertz,
which they didn't use for anything during the missions.
Right, but now it makes sense because it's evenly spaced. Right, they had three channels, 30, 50, and 70, but they didn't use the 50, but it's here. And that's the modulation down. That's 1024 is the data subcarrier. So data should come here. Yes, it's PCMN. And this was the voice, but has been changed. It should be 1.25, and it's 768 kilohertz. So that's a mod that we knew existed. There you go. And they say modified for AE program, and they said what they did, but basically they changed 1.25 megahertz to 768 kilohertz, and we see an equivalent mod on the PM receiver on the other side. Another aside, we have good reason to think that the AE program refers to the Atmospheric Explorer program, and in particular to the follow-on GEOS 3 satellite, which exactly matched our modified transmitter and receiver S-band frequencies. More on that in episode 13. And we traced it with Mike, and we figured out what was in the front. There's some stuff that's in the back that wasn't labeled, but we think we have discovered all the inputs and the outputs, so we should just test it, see if we can get our subcarriers going.
Yeah.
It turns out some of the inputs for the front end, for the front outputs are on the back. Some of the outputs for the front inputs are on the back. It's sort of weird, really. They ran out of options or space. There.
Alright.
Got it. So over here on the side we have Professing minus 15. We figured out what this was and I forgot. Do you remember? It was a separate power supply, wasn't it?
It might have been, yeah.
Alright, and that's the adjustment for the voltage of a power supply. And then we have this mod and unmod.
Yeah, the switch inside the...
Yes, we don't know what it does.
Well, you don't like the modifications, so just switch it to unmodified.
Alright.
Alright, and oh wow! It came on. Oh, you know what the other power supply might have been? The it takes a while.
Yeah, it does.
It might have been the 18 volts for the 24 volts for the lights. 15.
Okay.
15.2. That's a little high.
I think this is the minus. Yeah. Plus 15.2 minus 15.2.
Okay. 14. That's the voltage for the lamps.
Yeah, that makes sense. Now we can replace this bulb.
Yeah, go for it. Lights. All right. So I was thinking we just do this one. That's easy. Oh, that should be super low frequency. So if I go 100 kilohertz. Oh, 100 kilohertz. Okay. And if I get myself into out. Here is a quick refresher on the uplink spectra before we proceed. A 30 kHz subcarrier in green is used for the voice. Data is on the blue 70 kHz subcarrier. Finally, the ranging pseudo-random noise signal is added in baseband, shown in yellow here. So if things work according to plan, we should see the 30 and 70 kHz subcarriers. Then we should be able to add voice, data and ranging inputs and watch in awe as the corresponding modulation appears. Alright. It seems like we have our 30 kHz and our 70 kHz in there.
And if I...
Oh, okay.
So here's 70.
Yeah. Right. Answers.
30.
And if you turn the level down, is it the level of modulation or the level of the carrier that goes down?
It's like probably the
modulation.
Oh, no, there it goes.
Oh no, it goes lower.
Okay.
Okay.
And then this one.
So it's the actual level of the subcarrier that goes down. Okay. Yeah, so you have the combo of the 70 kilohertz and the 30. So if I just do that, you have only 30. And if I do that, you have only 70. So that's what I expect. Should I modulate you a little bit? Voice, I need to go here. There we go. I have it. Did you get frequency modulated? Yes, you did. Turn it on. Yes, that's good. That's modulated now with voice. No voice. Some voice, so that's working fine. And then you see the FM modulation here too. That's easy. No voice, no voice, voice. I turn this one off. I put the PCM, and then I do this, and it's modulated too. And I see it over there too. So we could put the updata box, link it to that.
So can we put the ranging teensy on here and?
Yeah, and that's your pseudo-random
Right.
generator.
Okay.
It's a collaboration between Ken and I. Ken did 99% of the thing, and then I did the connections.
Oh,
And I don't remember what I did.
wouldn't work without the connections.
I think we got it. So this is your pseudo-random code spectrum, and this is the digital version of it. So that's working fine. So that is not correct. I should be able to turn it off. We can check the switch. It does not work.
I was looking at your notebook, and I think we already understood something last time. I think these control the aux in the back.
And not in the front.
Mm.
Oh wow.
So
Good catch.
Can you tell me which one it is?
J11. Yes, it's not labeled. It's the only one that is not labeled.
Oh, I forgot to label it.
Looks like it.
I don't see nothing. Oh yeah, it's coming. Now it's control. Okay, so it was all normal. But okay, I bet you this is more normal though. Here in the spectrum. This is awkward.
Well, that explains how the potentiometer would fail.
Right.
I was a little baffled by that.
Yeah. And that makes more sense because I had too much signal, so now it looks like it's nice and underneath. Whoa, apart from a hidden connection at the back, this all worked flawlessly. Our uplink modulation section is fully working. Let's now check the USB side of the box, starting with the PM downlink. The ranging signal is turned around by the transponder itself, so we don't have to worry about that. The voice downlink subcarrier is at 1.25 MHz, and the data downlink is at 1.024 MHz. Except that our 1.25 MHz voice carrier has apparently been modified to 768 kHz. This one, right, that would be the equivalent but down on the modified 768, and you can still see the sticker at the other side, right? Yeah. It used to be the Apollo 1.25. So PM mod, I just have to find out where it comes out, and I think it's at the back, right? And that would be
G13.
W8 on G13, yes. Alright, and then that should be... Oh yeah, I can already see it. So that seems to be working too. We have... If I turn everything off, we have 768. which by the way is a big band harmonic. And yeah, you can tell
the top is kind of round.
Yeah, it's kind of round. And then this is 1.24. So I should be able to do voice modulation of this. Sure does. Voice modulation, without modulation. Okay. And then we should get the other one. I should be able to modulate it too.
I don't see it.
Aha. It's not modulating here. Okay, so that doesn't seem to work. Okay, we have one failure. Maybe. Or either that or user error. Okay. It says biphase mod and TV bias. So wait a second, does it expect a logical level rather than an analog level into it? And it's a TTL gate and I need to drive 5 volts into it for it to do anything?
That could be.
So it might just be that PCM in it expects analog, it expects digital, and I'm putting analog into
But
it.
if you could make it a square wave.
Yeah, I would want to look into it and see if it goes into an IC before I do that. Let's take a look first. But that would make sense. And yes, there is an op amp in there. There might be some ICs. Yes. So there's nothing obvious that we can see, and the part will have to desolder it to know what the part number is. So either we desolder it and figure out what part number that is, or we get the voltage up to 5 volts and
So
see if something
702
happens.
is a 8-pin cam. How many pins does that have?
8.
Yeah, it's an op amp, early op amp. So we figured it out. It indeed expects digital modulation, and we're at high enough, so it's a square wave now. And I go 1, 2, 3, 4, 1.5 volts. It starts to modulate. I probably need to be a little bit more than that.
Yeah, they're now
6, 7, 8, 2. There you go. So it definitely wants digital information. And you got it.
Yeah, you can see where the phase reverses.
Aha, we had been had, whereas the uplink is PCM on DPSK on FM on PM, downlink is just PCM on DPSK on PM. There is no FM step. So our input expected a digital signal. Tricky. So we have to write it down. Needs at least 2 volts input.
The phase reversals are kind of ugly.
You need to sync it, right? You can't have the 1.024 kilohertz be totally independent. Yeah, but it is a nice phase reversal, right? You have, it's either in or out of phase on average. So that we have correct. There is also a simple receive section that just filters out 30 kilohertz and 70 kilohertz without doing any further demodulation, so it's not particularly helpful. You'll have to trust me that it worked. Interestingly, the 50 kilohertz was not implemented, and it was never used in the final Apollo link either. Similarly, there was a simplified FM downlink section which just included a bias correction for TV, something we found was needed in episode 21. Nothing exciting there either, it worked just fine. So let's jump straight to the more challenging part, trying to undo the downlink subcarrier modification. We need to revert back to the original Apollo voice subcarrier frequency at 1.25 MHz. The next step would be to bring this thing back to its Apollo frequency. Unfortunately, Mr. F. Lensberg made really good notes, and we don't even need his notebook. As he said, he put cap across the VCO varicaps as 207 picofarads, and you can see there are some caps added on the varicaps, so that's modification number 1. And number 2, he took out the 1.5 megahertz filter and put a capacitor instead. And it's also easy to see. This is the filter, and you can see that the filter has been disconnected here. Now it goes to a cap. We think it goes to the other side over here and should go to that wire which has been disconnected too. So basically he lowered the frequency of the VCO by putting the caps, and then the filters annoyed him, so he just disconnected it.
Right.
Which is why, that explains why we see the second harmonic.
Yep.
It's not filtered.
Yep.
Right, so okay, that makes plenty of sense. So as usual, it gets more complicated when you look at it. This is our VCO circuit that has been modified, and there's not one but 2 caps added on the varicaps. So did he add 1? Did he add 2? We don't know, we think it's 2. And then of course it's not going to spring back to 1.25 volt by itself, because we have an adjustment for the center frequency and another one for the modulation, and maybe they are interdependent, so we'll have to retune it with those 2 guys. So what I was thinking of doing is removing 1 or maybe the 2 caps, see if we spring back approximately towards the right frequency, then center it to 1.25, and when we're there, then we put the filter on top. So we don't modify the filter until the end.
Sounds good.
We'll see. Okay. Good leaded solder. You know, it actually flows. None of that leaded stuff. Oh yeah. Okay, and the 1.
That should be 15 puff.
15 puff. I'll see that in a second. Put it over it, and it's only 15 puff, so that's the adjustment capacitor. So I think we have to remove the other one.
Yep.
Alright, so we just do the second one. Done. And that should be 150, 180?
180.
180. Oh, I see, the last digit is the number of zeros. 181 is 180.
Yep.
And 150 is 15. 100, and so we got it, and it's 184. So 184 plus 15.
It was settled on 16.3, so that gets us to 200.3.
Okay, so it said 200 something else, right?
207.
Yeah. Close. So that's probably what he added.
Yeah.
Okay. So I put that one back in. We're looking at the output. I turn it on. And okay, so that's one, the 1.24. So I'm going to turn that one out. I'm going to try the other one.
1.25.
1.25.
Oh, that was easy.
Oh, okay. Well, it's full of harmonics,
Yeah.
but that will be filtered. I'm going to take it out of here for a second and put it over there. 1.2446. Wow. Okay, so we definitely tickled the right capacitors. So it's the reading over here. And I would think it's this setting here that was, it's an L that's close.
Drop by the other way.
There you go. Yeah, just tightening Yeah, that makes it move a little bit. What does R4 do? R4 participates to this too. Okay,
That's good.
12499. Okay, can we still modulate the thing? And yes, we are frequency modulating very strongly. Okay, onto the filter. See if we can get this one figured out. Okay, I think that's the cap they added. So that's the modification.
Yep.
The devil is out, and then it's fairly straightforward. I reattach the two ends of the filter. One. Two. Okay, so our filter should be back in.
Sweet.
And let's see if that works better. Am I forgetting something? No, not really. Look. Okay, so we have, so let's get rid of this. Let's get rid of that. There you go.
Oh yeah.
That is the sine wave. So the filter is doing its job. Yeah, this is much better. Okay, and then we modulate it. FM, and we can adjust the amplitude. And I see it. FM modulated. Frequency span. Over. There. Boom. Okay. Search. Marker center frequency. 400. Right. Kilohertz. Modulate it. Max all. There we go. We have 40 kilohertz per volt at this point.
Okay.
So we can check whether that is close enough. I suspect it will because we hardly tweak the knobs.
Yep.
Okay. Okay, well, I think we got one more box fixed and back to its Apollo specs. We're almost ready to roll. On the other side, we have added the interface simulator to our transmitter, and then we have the two receivers, PM, FM, the three inputs, the up data command, the voice, hello, 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 and up there is the pseudo-random ranging signal. And on the spacecraft side, we are all ready to go. The transceiver has rejoined its pre-assigned space in the transponder mount, and we are all kind of ready to hook up the control panel and the PMP, but that will be for the next episode. Okay. So it says mod undone 10.2.2022, retuned to 1.25 megahertz. See CuriousMarc's notebook number 7, page 131.